You can see from our objectives today that everything is about the periodic table. So you're going to need to be able, by the end of class, to identify the different regions of the periodic table. So what's a period, what's a group, and then where are the metals, nonmetals, and metalloids located on the periodic table. And then you'll need to be able to describe for me common properties that all metals have, ones that all nonmetals have, and ones that metalloids have. So we're going to go through those things. So, to begin with, I don't know why it just auto-clicked that for me. Not what I asked for. There we go. Okay, the periodic table has both columns and rows. Okay. I'll pull down my example one. Okay. So we have columns that go vertically up and down, and rows that go horizontally sideways. The rows we call periods, and there are 7 of them. Okay. And then the columns up and down we call groups, or sometimes you might hear me call them a family. Okay. Elements that are in the same column, the same family or group, they share similar chemical properties. So for example, all of the elements in this column, the very last column up and down, they are all relatively unreactive, meaning you can put them, mix them with other chemicals, and they just generally won't react with them. Whereas all the way on the opposite side of the table, in the very first group, these would be highly reactive elements. Okay. You're going to see on your blank periodic table that you have, okay, you can go ahead and label the periods and the groups. We have 1 through 7 on the periods. You will notice on this periodic table that's up here on the board, we have groups 1 through 18. Sometimes you'll see them numbered that way. Sometimes you'll see them numbered, and then these inner ones will be numbered like 1A, 1B. That is because of something we're going to deal with later in class, but just in case you see that on another periodic table. But generally speaking, going with 1 through 18 is just fine. Okay. In addition to having columns and rows, they also organize elements by their chemical properties, and they put them into one of 3 groups based on their chemical properties. They're either going to call them a metal, a metalloid, or a non-metal. And there are sort of different regions on the periodic table where you will find most metals located, most nonmetals located, and where the metalloids are located, which, as you might imagine based on the name, is sort of the bridge between metals and nonmetals. Okay. So what we're going to do is I'm just going to pull up a nice colorized periodic table here, and we'll talk about the different regions. As we talk about them, I'm going to have you shade them in with the color of your choice. So you can highlight the word at the bottom, so like highlight metal in a certain color, and shade that region in on your periodic table in that color. Okay. So, let me scroll to show you the periodic table. I just have this online periodic table. I like it because it's very interactive. So one of the nice things you can do is if you hover your mouse over the cursor that says metals, then only the metals remain colored. So you can see that this whole section down here, I can point to it on here too. Okay. This whole section down here, as well as all of this, went white, and that's because it is not considered a metal. So anything that's left in color is considered a metal. So you can go ahead and shade them in as metals. So essentially, you'll notice that most of the left-hand side of the periodic table qualifies as a metal. If we hop back real quick to our notes, we can talk about what a metal is. You're probably pretty familiar with metals. Okay? Generally speaking, the physical properties of a metal would be that they are shiny. Most of them are going to be solid at room temperature. Mercury would be the exception to this, and I think gallium is pretty soft at room temperature, almost a liquid, but most of them are solid at room temperature. They are what we consider malleable. So if something is listed as malleable, that means you can deform it and shape it without breaking it. So if I have a solid chunk of metal and I swing at it with a hammer, rather than break into 1,000 pieces, it's going to dent. They're also ductile. Ductile means that they can easily be drawn out into wires. So that's why you will see us use metal and not glass to make wires, because they can be stretched and deformed. They also are good conductors of heat and electricity. We're going to learn later this is because of how their electrons are located, but essentially heat and electricity travel well through metals. I'm going to flip back to my previous page to get back to that periodic table for you. And we're going to talk about the next group, which is the non-metals. So if I hover over the non-metal button, you'll see that it's a relatively small region of the periodic table. And you will also notice that there's one little lonely non-metal that got moved to the opposite side of the table. When we talk about electron configurations, we'll talk about why hydrogen is over with lithium and sodium and potassium. But for right now, all you really need to know is that hydrogen often behaves like lithium and sodium and potassium, and that's why it's over by that column. But the rest of the nonmetals are going to be in the upper right-hand corner of the periodic table. We'll slip back over to our page and talk about nonmetals. Okay? Nonmetals are mostly gases at room temperature. We do have a liquid, which is bromine, and then some solids, but a lot of these nonmetals are going to be gases at room temperature. They are not malleable or ductile. Obviously, it's difficult to tell if a gas is going to be ductile or malleable, but most of the time when you get them cold enough to make them solids, they are definitely not malleable or ductile, which means if you are going to strike one of them with a hammer, they are going to be much more likely to shatter or crack or break into a bunch of pieces as opposed to bend or stretch. So we might describe them as brittle. They also do not conduct heat or electricity well. Okay, so oftentimes clothing that you have that is supposed to be warm is designed to trap a lot of air, because air is made up of mostly nonmetals like oxygen, nitrogen, those types of things, and so they do not conduct heat very well, which means the heat that is in your body is not going to easily escape it through that layer of gases. And they also make poor conductors of electricity, which is why things that insulate wires are usually made of nonmetals. And we'll hop back over to the periodic table for our last group, which is the fun little metalloids here. So there's not very many of them, and you can see they form a sort of stair-step pattern that bridges the gap between the metals and the non-metals. Also, just as a side note, you might have noticed that some of the elements in this lovely row right here were not put in any of those categories. We didn't call them metals, non-metals, or metalloids, okay? That's because this column here, this row here on the periodic table is largely elements that we have only been able to synthesize in a lab setting, meaning they don't occur naturally out in the world. And the reason they don't occur naturally out in the world is because they undergo radioactive decay so quickly that they only exist for a couple of seconds before they break down into a different element. As a result, you can imagine, because their life in the lab is only a couple of seconds long, pretty hard to take measurements of their physical properties and their chemical properties, right? So we know they exist. We know where they belong on the periodic table because of the number of protons that they have, but knowing their exact chemical and physical properties is difficult. So we haven't officially put them in a classification as a metal, a non-metal, or a metalloid. Okay, we'll hop back over here. Oh, I'm not trying to move that. There we go. Now we can talk about the metalloids. Metalloids split the difference between metals and nonmetals. So not only are they between metals and nonmetals on the periodic table, but in terms of their chemical and physical properties, they are also halfway between a metal and a nonmetal. Meaning that they are mostly solid at room temperature, but not all solid at room temperature. They are less malleable, less ductile than a metal, but not as brittle as a nonmetal. And they can have a sort of shiny metallic luster like a metal, but not all of them do. And they are what we call semiconductors of heat and electricity. So they do conduct heat and electricity, but they just don't necessarily do it very well. So again, bridging that gap between the metals, nonmetals, or the metalloids. The last thing I want to talk about on the periodic table is this piece right here. Okay, this is a sample element block from the periodic table, and I just want to refresh you on what information is available on it. So I don't have a spot on this for your notes, but you can draw one and label it if you'd like. Okay, so most periodic tables put the atomic number, which is right here, up in one of the top corners. Okay, here it's in the top left. On the one on my wall, it's in the top right. Okay. That tells you both its position on the periodic table and its number of protons, which we'll get to when we review atomic structure. Okay. So the atomic number is going to increase as you go left to right across the table, and then also as you go down the columns. It will give you the symbol, in this case Fe for iron. Okay. And then underneath the symbol, they'll usually give you the full name. The symbol sometimes looks like it's just an abbreviation of the first couple letters of the element, and then sometimes it looks wildly different. That's because some of these elements were named when we still used Latin, and so they had Latin names, like iron was ferrous, so that's where the Fe for iron comes from. Okay, so you'll see some examples of that, like gold and silver are Au and Ag, lead is Pb. Okay, and then you'll also see some where they used a couple of different letters because there was already one that started with the same two letters. Okay, like molybdenum magnesium and manganese are very similar, so they have just slightly different letterings. Okay. And then usually towards the bottom of the block, there is the atomic mass. Okay. This is an average because of some things, and we'll learn more about it in later sections. But for right now, just know that's your atomic mass there. Questions about the structure of the periodic table. All right, this is where our notes end for today. So your homework is going to be page 25, questions 1 through 5, just over stuff from the periodic table. Your text is always helpful when answering these questions, and so are your notes. Your notes come straight from the text, so